Before a single warship could be repaired, dry docked and returned to sea in the early 1800s, someone had to carve a room out of the harbor floor big enough to hold it. No hydraulic excavators, no pneumatic drills, no concrete pumped from a mixing truck. The men who built the first great granite dry docks on the American coast used black powder, hand-forged chisels, and the labor of thousands of workers hauling stone in buckets from a pit that kept trying to drown them. The dry dock at the Charlestown Navy Yard in Boston, finished in 1833, is cut from solid granite and stretches 304 feet in length, 40 feet deep at its lowest point, and wide enough to float a ship of the line inside it, while the gate swings shut and the water is pumped out by hand. It is still there, it still works. What it took to build it belongs to a category of work that has no modern equivalent, because the problem it solved was a problem that no machine existed to help with. If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. To understand why a dry dock mattered, you have to understand what the Navy was doing without one. A warship that needed hull repairs in the early 1800s had to be careened. The crew would offload the guns and ballast, run lines from the masts to anchor points on shore, and haul the ship onto its side in shallow water so the exposed hull could be caulked, recoppered, and patched. Careening worked on smaller vessels. It was somewhere between difficult and impossible on a ship of the line displacing 2,000 tons. The United States Navy had no facility on the Atlantic coast where a heavy warship could be taken out of the water for maintenance. Every major repair required either a dangerous improvisation or a voyage to a British yard. By 1820, Congress had authorized the construction of dry docks at Boston and Norfolk, and the Navy had chosen the sites. What they had not done was figure out how to build them. The man they gave that problem to was Loammi Baldwin Jr., a civil engineer from Woburn, Massachusetts. Baldwin had trained in Europe, studied canal engineering, and come back with a practical understanding of hydraulics and masonry that almost no one else in the country possessed at the time. He traveled to England and France to examine existing dry docks, took careful notes on the foundations, the gate mechanisms, the pumping systems, and came home with a plan that the Navy's Board of Commissioners looked at with something close to disbelief. Baldwin proposed cutting straight down through the harbor floor to bedrock and building the dock from granite blocks laid in courses on the excavated rock itself, with no timber piling, no rubble fill, no intermediate structure of any kind. The walls would be granite, the floor would be granite, the gate would be timber fitted against a granite sill. The whole thing would be self-contained and permanent. It would last, he said, essentially forever. The board approved the design in 1827, and construction began the following year. The first problem was the water. The Charlestown site sat in the tidal harbor, which meant the moment you started digging, the harbor came in after you. Baldwin's solution was a cofferdam, a temporary enclosure built around the perimeter of the proposed dock site to hold the water back while the excavation proceeded inside. The cofferdam at Charlestown was a double-walled structure built from timber sheeting driven into the harbor floor by pile drivers operated by hand-powered trip hammers, gangs of men hauling on ropes to lift the hammer and dropping it onto the head of a timber pile, driven with each blow a fraction of an inch deeper into the harbor mud. The outer wall and the inner wall ran parallel, roughly 6 feet apart, and the space between them was packed with clay puddle, a worked mixture of clay and water that swells when saturated and becomes nearly impermeable. The cofferdam enclosed a rectangle 350 feet long and 200 feet wide. Building it took most of the first year. When the pumps started pulling water from inside the cofferdam, the full nature of the problem became clear. The harbor floor inside the enclosure was not stable ground. It was a layer of mud and sand and shell and organic debris sitting on top of a harder subsoil, which itself sat on top of the bedrock that Baldwin needed to reach. That bedrock was, in places, 40 feet below the surface of the harbor. Between the surface and the rock was 40 feet of waterlogged earth that had to come out before any masonry could go in. The workers dug by hand. They used long-handled shovels and the kind of narrow iron buckets that well diggers used, passed from man to man up a chain of workers to the surface. When the water seeped in faster than the pumps could handle, the men stood knee-deep and kept digging. The pumps at Charlestown were chain pumps, a series of linked buckets on an endless loop, driven by horses walking a circular track above the pit. When the horses tired, they were rotated. When the chain pump could not keep up with the inflow, additional men were set to bailing with hand buckets. For months, the water and the workers fought each other to a standstill every time it rained. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. When the excavation finally reached bedrock, the floor of the pit was a broken, irregular surface of granite and schist, running at angles determined by geology rather than convenience. The granite cutters went to work on it. Their tools were hand-forged steel chisels in 3 weights, a point chisel for breaking the initial surface, a drove chisel with a wider blade for flattening, and a pitcher for splitting along natural grain lines when the rock allowed it. The hammers they used ranged from 2-pound hand hammers for close work to 8-pound sledges swung with both hands for breaking large projections. A skilled granite cutter could cut a flat surface to within a 1/16 of an inch of a given plane using nothing but a straight edge and his eye, but cutting the floor of a dry dock to that tolerance across 300 feet of irregular bedrock meant thousands of hours of handwork in a hole that was still seeping water at the edges and had to be pumped continuously throughout. The walls of the dock were built in courses of dressed granite, each block cut at the quarry in Quincy, Massachusetts, roughly 9 miles south of the site. The Quincy granite quarries had been operating for decades, but the dry dock contract transformed them. The Navy required blocks of specific dimensions, some of them running 6 feet long and 2 feet on a side, weighing close to a ton each, cut to tolerances tight enough that they could be laid without mortar and the joints would still be nearly watertight. Quarrying granite at that scale meant drilling rows of holes across the face of the stone with handheld star drills, steel rods with a cruciform cutting tip that were rotated by hand, a quarter turn between each hammer blow to cut a circular hole in the rock. A crew of 2 would drill a single hole 6 inches deep in about an hour. The holes were spaced at intervals of 8 to 12 inches along the intended break line. Feathers and wedges, small iron shims fitted in pairs into each hole, were then driven simultaneously down the row. The wedges expanded the rock along the line of holes, and the block separated with a crack that ran clean when the stone was properly red and ragged when it was not. After the blocks were split free, they were dressed on site by gangs of cutters. The faces that would be exposed inside the dock were worked smooth with chisels and then rubbed with abrasive stone to a flat finish. The faces that would be buried in the wall were left rougher, pitched to remove major projections, but not refined beyond that. Every block was then loaded onto a stone wagon with a crane operated by a hand-turned capstan and hauled by oxen to the Granite Railway, a horse-drawn rail line specifically built to move stone from the Quincy quarries to the Neponset River, where the blocks were transferred to barges and floated up the harbor to the construction site. The Granite Railway, opened in 1826, was the first commercial railroad in the United States, and it existed for one purpose: to move stone for the dry dock. At the site, the blocks were lifted from the barges by a derrick rigged on timber framing and lowered into the pit by teams of men working a rope purchase. Positioning a ton of granite in a wall course with rope and timber and muscle meant moving it in small increments, tapping it into alignment with iron bars used as levers, checking the fit against the adjacent block, pulling it back, dressing a high spot on the contact face with a chisel, and setting it again. The joints were caulked with hydraulic cement, a pozzolanic lime mixture that sets under water and was mixed on site in batches small enough to use before it stiffened. The courses rose from the bedrock floor up the sides of the excavation, each one stepped slightly inward to follow the battered profile of the dock walls, which were not vertical but angled to resist the lateral pressure of the surrounding harbor earth. The gate at the entrance of the dock was a different problem entirely. The opening was 60 feet wide and had to be sealed against a water column 40 feet deep, when the dock was pumped dry, then opened again when a ship was to be admitted. The solution was a floating gate, a timber caisson built in the shape of a ship's hull, wide enough to fit the entrance opening and ballasted so that it could be floated into position and then sunk by flooding its interior chambers to seal against the granite sill. When the dock was ready to be opened, the gate was pumped out and it floated free. The granite sill against which the gate seated had to be cut to a precise curve matching the bottom profile of the caisson, accurate enough that the joint between stone and timber would hold the full pressure of the harbor against it. That curve was laid out by the stonecutters using a template made from the caisson itself and cut into the bedrock at the dock entrance by hand. The workforce that built the Charlestown dry dock peaked at roughly 800 men during the heaviest phases of construction. They were quarrymen, granite cutters, masons, carpenters, laborers, pumpmen, and horse tenders. Many of the skilled stoneworkers came from the established quarry communities of eastern Massachusetts, men who had been cutting granite since childhood and knew the Quincy stone the way a carpenter knows a particular species of wood, how it split, where the grain ran, what the sound of a chisel told you about what was beneath the surface. The laborers came from wherever labor was available, and in the late 1820s, that increasingly meant Irish immigrants arriving in Boston with strong backs and no other immediate options. These men were paid in a tiered system that reflected exactly where they stood in the order of skill. A master granite cutter might earn $1.75 a day. A common laborer shoveling muck out of the pit floor earned 75 cents, sometimes less. The distinction was not merely economic. A cutter who misread the grain on a large block and split it wrong had destroyed several hours of drilling and weeks of quarrying. A laborer who dropped his shovel into the sump and clogged a pump chain cost the project money in a different and more recoverable way. The hierarchy of the work was the hierarchy of consequence, and the men at the bottom of the pit in the worst water knew exactly what kind of consequence they were living with every shift. The dangers were what you would expect from a 40-foot excavation in a harbor that never stopped trying to reclaim the space. Cofferdam failures were the worst possibility. If a section of the timber sheeting failed under the pressure of the surrounding water, the inrush could drown the men working at the bottom of the pit before they could climb out. Partial failures happened. Water broke through at the base of the dam in one section early in the excavation and flooded a portion of the pit before it could be stopped. No one died in that incident, but it showed what a full breach would look like. Men were struck by stone during lifting operations. Chisels glanced off rock and cut hands and faces. Workers fell from the staging built inside the pit to allow access to the upper courses of the wall. The pumping crews worked in standing water for weeks at a stretch, and the respiratory illnesses that followed were not recorded as work injuries, but they were work injuries. Construction ran 5 years, from 1828 to 1833. The final cost was $904,000, more than double the original estimate, and the overrun came almost entirely from the time and labor required to deal with water and unstable ground, the same two enemies that every underground construction project fights, regardless of era. Baldwin's design held, the walls did not settle, the gate sealed. When the pumps brought the water level down for the first time, the dock floor was dry and the granite courses ran true from the entrance to the head wall without a visible gap. Steam-powered pumps replaced the horse chains within a few decades. Pneumatic drills eventually replaced the handheld star drills in the quarries. Concrete replaced granite as the standard material for dock construction in the 20th century because it could be formed and poured rather than cut and fitted. The economics were simple. A concrete form could be set and filled in a day. A dressed granite block required 2 men drilling for an hour just to begin the separation from the parent stone, then another crew to finish it, then oxen and barges and a derrick crew to move it from quarry to site. When concrete arrived as a viable substitute, the older method did not compete. What it left behind was the work itself, permanent, in a way that poured concrete has never quite matched, because granite blocks laid in tight courses do not crack along internal stress lines the way monolithic concrete does. The individual pieces move with the ground instead of against it. and a well-fitted granite joint, sealed with hydraulic cement, can stay watertight for 2 centuries without repointing. The skills that built Charlestown, reading granite for grain and fracture, dressing a flat surface with a drove chisel, operating a rope purchase crane with a crew of 8 men moving a ton of stone in inches, those skills thinned out as the machinery that replaced them became standard. A handful of preservation masons still work granite to the old tolerances. The knowledge is not gone, but the men who hold it can be counted rather than numbered. The Charlestown dry dock is still in service. The United States Navy still uses it. Ships still float in, the gate still closes, and the water still drops away from the same granite walls that were cut and set by hand in a flooded pit 9 miles from the quarry that supplied them. The stone is the same stone. The joints are the same joints. The curve of the entrance sill where the gate seats is the same curve the stonecutters laid out from a timber template 200 years ago. You can go stand next to it. The work is still holding. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.